We have already substituted the values of a and b into the equation, okay, that is from the previous part, and this is the equation that I have, and I'm supposed to factorize this equation to find all the roots of this equation in the exact form. We already know one of the roots. It is given to me that w, which is 1 plus 2i, is the root of this equation. And what we have here is a polynomial, and very specifically, it is a polynomial with real coefficient. And like what we have discussed in our outline, whenever we have a polynomial with real coefficient, if there were to be a complex root, automatically the conjugate of that root will also be the root of this polynomial. So I already know, okay, there are two roots already. One is w, the other one is w conjugate. This allows me to rewrite this into its factor, at least two of the factors, okay, which is where one is z minus w, w is 1 plus 2i, okay, the other one is z minus w conjugate, okay, so it is 1 minus 2i. Okay, and one more factor. The other factor, it got to be a linear factor because this is a cubic polynomial, okay, with two linear factors here. So the last one has to be a linear factor also. I'm going to call it maybe just pz plus q, okay, and this is equal to 0. Okay, for this that I have here, I'm going to expand it so that it can form for me a quadratic factor. And to get from here to a quadratic factor, I can make use of the useful result that we've discussed in our outline, or you can probably just simply expand this. Okay, but I'm going to use the useful result. Using that result, it is going to be a z squared minus 2 times of the x portion of the root. It is going to be 1 times z plus the x portion square and the y portion square. So it is 1 square plus 2 square. And this multiplied by pz plus q, this is equal to 0. So here what I have is a z squared minus 2z plus 5 multiplied by pz plus q is equal to 0. You may wonder, okay, what is my motivation of expanding this, since the factor is really going to give me the roots? And what I'm trying to do is I'm trying to apply an observation here to find p and q. Because from observation, I know z squared multiplied by pz is going to give me 27z to the power of 3. This tells me from observation what the value of p should be. The value of p has to be equal to 27. So this is 27 of z. And how about q? 5 multiplied by q is going to give me 295. So from observation, I can also find the value of q. Q is going to be 295 divided by 5, and that is going to be 59. Okay, and this is equal to 0. So this is that final factor to this equation over here. That is why I know what are the roots. One of the root is definitely going to be from here, which is going to be minus 59 over 27. And I have two more roots which we have discussed just now. It is w and w conjugate. So the final two roots will be z is equal to 1 minus 2i and z is equal to 1 plus 2i.